this lesson we're going to move on to chapter 9, which is indices, and today's lesson really is just going to be kind of a quick recap on all the main things of indices that we've actually done before. It's really important, this chapter actually. It's one of the first chapters you do with Leaving Cert as well, so it's nice that it's kind of at the end of Junior Cert. So what is an indice? Well, an indice is any number in the form. Sorry, my pen isn't working for some reason. Hang on. Yeah. So an indice is any number in the form b to the power of n. Now, examples would be 2 to the power of 5 or minus 3 to the power of 6. So any number in that form is what's known as an indice, or it's in index form. B, the number at the bottom, is called the base. And they might just ask you this in a question. N, the index, as it's known, can also be called the power, and it can also be called the exponent. So there's just 3 different words that you can use to describe the index, power, or the exponent. So today's lesson is really just a recap on the stuff that you've seen before. And the first recap has got to do with negative numbers. Or negative indices, I should say. Now I'm going to show you the rule, or I'm going to remind you the rule just using minus 1. Let's say we have minus 1 to the power of 1. That gives you a value of minus 1, because any number to the power of minus, or any number to the power of 1 is just itself. Let's say we have minus 1 squared. What answer does that give you? Well, minus 1 squared is equal to minus 1 multiplied by minus 1. And we know that a negative number multiplied by a negative number gives us a positive number. So our answer will be plus 1 here. What about minus 1 cubed? Well, that's equal to minus 1 times minus 1 times minus 1. Now, anytime you have 3 numbers being multiplied together, you just do it bit by bit. So minus 1 times minus 1 is plus 1. Plus 1 multiplied by minus 1 gives us minus 1. Minus 1 to the power of 4 will be minus 1 times minus 1 times minus 1 times minus 1. So what would this give us? Well, we have minus 1 times minus 1, which would be plus 1. Minus 1 times minus 1 would be plus 1. Plus 1 times plus 1 gives us plus 1. Minus 1 to the power of 5. Minus 1 multiplied by minus 1 multiplied by minus 1 multiplied by minus 1. Minus 1 times minus 1 is plus 1. Minus 1 times minus 1 is plus 1. Plus 1 times plus 1 gives us plus 1. Multiplied by minus 1 is minus 1. So the reason I'm doing this is to show you a pattern. And the pattern I'm showing you is that if you have a negative indice, and that negative indice is put to a power that is even, so for example 2 or 4, you will get a positive answer. So any negative number with an even power will be positive. And that's the rule that you need to remember. So an example might be minus 2 squared. Well, that's an even indice, so we're going to get a positive answer. So 2 squared is 4, minus 2 squared will also be 4. Minus 2 cubed, well, that doesn't have an even indice, that's an odd number. 3 is an odd number, so that's going to give us a negative answer. So it's going to be minus, and 2 cubed is 2 times 2 times 2, which is 8. Minus 2 to the power of 4, we have an even index, or an even power again, so that's going to give us a positive answer. And then 2 to the power of 4 is 16. And this will work with any number, any negative number. Same with minus 3 squared will be plus 9. Minus 3 to the power of 3, odd power, so that's going to give us a minus number, so that'll be minus 27, and so on and so on. So that's the first thing I just want to recap with you today. The second thing I want to do is I want to look at the laws of indices. And we're just going to do the first 4 today. And you should remember these now because we've gone through them a couple of times. So the first one is any number to the power of m multiplied by the same number to the power of n is equal to that number to the power of m multiplied by n. Now what's important here is that the base number is the same in each case. So this would work, say 2 to the power of 3 multiplied by 2 to the power of 2. That's the same as 2 to the power of 3 times 2, or 2 to the power of 6. But it only works if the base number is the same, so if that's just a 2. Number 2, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So we could have 2 to the power of 6 divided by 2 to the power of 2. That's the same as 2 to the power of 6 minus 2, which is 2 to the power of 4. And again, the base number has to be the same. You can't have 2 to the power of 6 divided by 3 to the power of 2. Number 3, any number to the power of m, in brackets all to the power of n, is equal to a to the power of m times n. Oh sugar, I'm after getting the first one wrong. That should be m plus n. Oh sorry girls. So that's going to be 3 plus 2, which would be 5. Oh apologies, go back there. Some of you probably noticed that while I was doing it, that was a mistake. So that's m plus n. This one is m multiplied by n. So this would be, say, 2 to the power of 3 all squared gives us 2 to the power of 3 multiplied by 2, which is 2 to the power of 6. So apologies for that, make sure you go back and correct that. And number 4 then is any number to the power of 0 equals 1. And that's a really important one that people often forget. So if you had 7 to the power of 0, that's 1. If you had 1136 to the power of 0, that's equal to 1. Any number whatsoever to the power of 0 is equal to 1.